All right, let's talk about container security. Today, we're going to do a deep dive into container images. And we'll be using the amazing open source tool Trivy as our own personal security X-ray. We're going to find out what's really hiding in there. Let's get into it.
So you pull a container image, right? It seems totally harmless. It's just one line in your Docker file. But have you ever stopped to think about what you're really letting into your system? I'm talking about hidden vulnerabilities, maybe some sketchy misconfigurations, or even leaked secrets just waiting under the surface. So how can you actually be sure it's safe?
Well, that's where Trivy comes into play. Think of it as that X-ray for your containers we were just talking about. It's not just doing a surface level check. Nope. It goes deep, digging into the files, the metadata, and even the whole software supply chain. It's all about giving you that complete security picture. Okay, here's our game plan for today. We're going to start with scanning the files, then look at image metadata. After that, we'll talk about optimizing your workflow, supercharging things with SBOMs, and finally pulling it all together into a solid security strategy. All right, before we jump into the command line, just a quick heads up. This is all for educational purposes. You know how fast things change, so always check the official Trivy docs for the latest commands. And just for the record, we're not affiliated with Aqua Security or the Trivy project. All right, let's get into our first layer, scanning the image files. This is exactly what Trivy sees inside your image by default. It's the most obvious place to start, right? When you run a basic Trivy scan, it's literally digging through all the files and packages that make your container, well, run. It's like popping the hood and checking every single part. So what's it looking for in there? Well, Trivy is on the hunt for 4 big things. First up, vulnerabilities. The classic security holes in your packages and libraries. Then you've got misconfigurations, which are super important if you've got stuff like Terraform files baked in. Third, and this is a big one, hard-coded secrets. Think API keys, passwords, yikes. And finally, it can even check software licenses to make sure you're compliant. Okay, now this is really important. Look at that enabled by default column. Here's the kicker. Right out of the box, Trivy is only looking for vulnerabilities and secrets in your files. That's it. If you wanted to check for misconfigurations or licenses, you have to tell it to. You got to add that flag to your command. It's so easy to miss this. Okay, let's peel back another layer. We're moving on to layer 2, analyzing the image metadata. We're not just looking at the files anymore. Now we're checking the actual blueprint of your image. And here's a great way to think about the difference. Scanning the files, that's like walking through a finished house and checking the furniture. But scanning the metadata, that's like inspecting the architect's blueprints, checking the foundation, the wiring, the stuff that really matters for safety. What Trivy does is pretty cool. It basically reverse engineers the image's config to analyze those plans. So what kind of red flags is it looking for in those blueprints? Well, it's hunting for all those common security no-nos. Things like, is this thing configured to run as the root user? Big red flag. Is it using the sketchy add command instead of the much safer copy? It'll also spot things like missing health check instructions or even secrets that got accidentally left in environment variables. And here's the gotcha. Just like before, these incredibly powerful metadata checks, they're turned off by default. You have to explicitly tell Trivy, hey, go look at the blueprint. It's another one of those things that's so easy to miss, but it is absolutely vital if you want the full picture. Okay, so now we know what we can scan, but let's be real. In an actual CI/CD pipeline, speed is everything. Scans have to be fast and smart. So let's talk about how we can optimize the workflow. This is where Trivy really shines in a real-world pipeline. It's super flexible, it'll scan images from Docker, Podman, registries, you name it. But it's also smart. That scan cache, a total game changer. It remembers layers it's already scanned, so you're not wasting time scanning the same base image 100 times. Plus, it can generate compliance reports and even stop you from scanning some ridiculously huge image that would just clog up your whole pipeline. All right, now let's get to the really cool part. We're going to talk about supercharging your scans with something called an SBOM, or Software Bill of Materials. This is how you get the most efficient scans possible. Okay, so think about how this usually works. The traditional way is to pull the entire image, every single layer, down from the registry to your machine just to scan it. Yeah, it gets the job done, but man, it can be slow and chew up a ton of bandwidth. But Trivy gives us a much better way. Instead of pulling that whole massive image, you can just scan its SBOM. An SBOM is basically just a lightweight list of all the software inside. It's like instead of reading a 500-page book to find one fact, you just look at the table of contents. It's brilliant. And there are a few ways Trivy can do this. 1, it can just generate an SPM for you. 2, it can find one that's already baked into the image. But the third way, this is the real magic. It can find an SPM stored separately in the registry that just points to your image. This means you can do a full vulnerability scan without ever pulling the image at all. That's not just fast, it's a massive leap in efficiency. All right, let's bring this all home. It's time to build your multi-layered security strategy. Because as we've seen, Trivy isn't just one tool. It's a whole toolbox for building a really solid security posture. This table really sums it all up, doesn't it? For your image files, you get vulnerability and secret scanning for free. They're enabled by default. But for everything else, licenses, misconfigs in files, and all of the metadata checks, you have to flip the switch yourself. And for those lightning-fast SBON scans, you just point Trivy to the right source. Knowing what's on by default and what isn't, that's half the battle. So what's the big takeaway here? It's simple. You can't just rely on one type of scan and call it a day. Real container security is about combining these layers. You need the file scan to catch the obvious vulnerabilities, the metadata scan to check your blueprint for bad practices, and the SBOM scan to make it all happen fast enough for a modern pipeline. They all work together. So, you've done it. You've followed all the steps. Your image is clean, it's configured perfectly, no known vulnerabilities. You've totally secured that at-rest artifact. But that leads to the next giant question, doesn't it? Your image is secure, but what happens the second it starts running?